Welcome back to General Chemistry. Let us see how we can see the periodic table in order to understand the behavior of the elements based on the way that the electrons are satisfying the different orbitals around the nucleus. Remember that one thing that we have been saying is that we will start filling up the electrons started with the first orbital when you have the quantum number n equal 1, and in that case we have only one orbital that we call the s orbital, and we know that we can put up to 2 electrons in each s orbital. Then we remember that we normally move around this order where after the first 1s we continue with the second s, filling it here, and then we continue filling the 2p and then the 3s and so on. Remembering always that the number of electrons that we can put in the s orbital is up to 2 electrons. So if I have an electron configuration with only one electron here, that means that I will not have any more electrons in the other orbitals. Remember also that the p orbitals can have up to 6 electrons and the d orbital can have up to 10 electrons. And this is how we're going to be writing the electron configuration of an element. So for instance, we may have an element that has let's say 5 electrons, so that would mean 1 is 2, then you have 2 is 2, and then the other one is going to be in the 2p, you have 1 electron there. So you have 2 electrons in the s orbital and 1 in this, making a total of 5 electrons. And that's how we're going to continue filling these orbitals here. So these are a good example here. This would be when I have element number 3 that has 3 electrons, they will be in 2 electrons in the 1s and the other electron in the 2s, so that would make the 3 electrons here. So we have 2 plus 1 equal 3, right? And if you have boron here, as we said before, where we have 5 electrons, then you have 1s2, 2s2, and 2p1, making a total of 5 electrons. Carbon, then having 6, will have the 1s2, 2s2, 2p2 electronic configuration, and so on. So we can just look at how many electrons do I have in each of the elements, and that's how we will try to find how the orbital is working in each element. So what happens with all the elements that have a similar configuration to hydrogen? That is, that remember hydrogen would be 1s1. So what would happen with an element that has something like 3s1 as the electron configuration? And of course, you will have all the other orbitals here full. So if we look here at number 3, the quantum number 3, here we see that 3s1 would be sodium. So if we look at sodium being the number 11 element, so that means that we have 11 electrons to fill. So that would be 1s2, 2s2, 2p6, and that would be 10. 2, 4, and 6, that would be 10. So the next one for the 11, that would be the 3s1. So you see, all of these electrons are satisfying internal orbitals that we call the core electrons. And if you look carefully, the one that satisfies the 1s2, 2s2, 2p6 would be the element just before sodium, which is neon, which is element number 10. So you see the neon here will have the 2s2 orbital and the 2p with 6 electrons, making a total of 6 plus 2, that would be 8. 6 plus 2 equal 8. And if we look at all all of these elements over here, they will all have the same situation where you have the the S2 and the P with 6 electrons. So all of this over here will have that the S has 2 and the P has 6 electrons. And this 6 plus 2 equal 8 is what we call the octet. The octet, which means 8, right? So the octet rule then is going to be what the elements are going to try to find out as they relate to other elements. And we're going to be talking about how we can use the octet rule. Let me write it again. Octet rule. We're going to use it again and so on. So as we move on and look at different elements here, like for instance looking at this column here with nitrogen, what can we see? Well, let's have a look and see what happens here. Let's have a look at nitrogen in this column here. Nitrogen has 7 electrons. Is element number 7. So that would mean that it has 2 in the 1s orbital. Then it has 2 in the 2s orbital. 2 in the 2s orbital. That's 4. And of course the other 3 would be in the 2p orbital, so you have 3 there. So you see the highest level, the n equal 2 here, will have 5 electrons. So you have 2 and 3 equal 5. So if I'm going to be adding, let me have a different color here for my pen. So if I have 2 plus 3 equal 5, this means that you have 5 electrons in the highest orbital, which is the orbital 2, n equal 2. So for n equal 2, I have that the orbital has 5 electrons. Look at the following electron here below the periodic table. In this case, you are in n equal 3. This one here corresponds for n equal 3. So this one here will have 3s2, 3p3, again 5 electrons in the highest orbital. And this is what is going to be giving the nitrogen and the phosphorus similar characteristics, right? So you can do the same thing for all of them. We mentioned before how these elements over here that we call the noble gases, so these are called the noble gases, they will have somehow the last orbital. Of course, in the case of helium, we only have 2 because helium doesn't have any more electrons. So helium, the octet rule is satisfied with only 2. But that's only helium. You can say that as an exception in the case of the octet, because the octet would be for 2. But for all of the others, you have 8 elements here. So if we think about what would be the next element here that would have the same behavior here, you are talking about something that has 4s2, 4p6. That would be the 8 electrons in the highest orbital, n equal 4. And when you look at the periodic table, you are talking here about krypton, which is the next noble gas in the column here. And you can do the same thing for all of the other ones, right? Let's have a look at this column here. This column here has the highest energy level would be 2s2 for beryllium. For magnesium here you have 3s2. So what would be the element that you expect to have over here that would have 4s2 at your higher level, right? So let's find out. So I want something that has 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, right? How many electrons do we have? 2 4, and 6, 10, 12, 18, 20, right? So which is element number 20? So we look in the periodic table here, and we see that in the periodic table, element number 20 is calcium, right? So with that in mind, we see that the element that we're expecting here would be calcium, that has that behavior of the last orbital, right? So this is how this works. Just for you to try out, think about the halogens here in this column here. And I'm going to leave you to think about that, and then try to guess what would be the element that you would be expecting here that would have the 4s with 2, and then the 4p with 5, right? So what would be that element? I'm going to leave that to you.